Hello, Vijay. Nice to meet you. Thanks a lot for joining
Nice
us
to meet you
today.
too. Thanks for having me.
Yeah, Vijay, so you are VP of AI Engineering at Regrello. What does that entail?
Sure. Yeah. So we're a Series A startup based here in San Francisco, and we're focused in the world of supply chain, logistics, manufacturing, all of that. And so maybe to explain a little bit, I can give the history of the company.
Absolutely.
So back in 2020, if you remember, COVID had hit, and my CEO now was my CTO at a previous company back then, and he left maybe June or so of 2020 and went to Stanford where he was teaching a course, and so it was a very sort of practical lab course being sponsored by the US federal government and the UK federal government, and they were focused on can we apply modern techniques of graph theory, graph analysis, machine learning, all of that, specifically to the supply chain around respirators. And so if you think normally respirators, right, a hospital might every 5 years they need to order a couple of them. If it takes 6 months for them to be manufactured and then shipped and then tested and then distributed and then brought to the hospital, great, nobody cares. But when COVID comes around, you have suddenly on both sides of that supply chain, hopefully once in a lifetime sorts of events, right? So suddenly the demand skyrocketed. Hospitals that normally need a couple for a few people in the ICU needed dozens or hundreds of these. And at the same time, the supply chain on the manufacturing and the shipment and the quality assurance and all that side of things, all these factories were suddenly at 50% capacity because half the people are out sick. Shipping routes were suddenly taking months and months as opposed to weeks, or couldn't even get, say, the fully assembled products. And then even just like the distance between where, say, a distribution center and quality assurance would happen, the distance between that and the hospital suddenly meant, well, people would die because they couldn't get the respirators in time.
Right.
So this is back 2020. Back then, I don't think he was really thinking of, oh, let's go build a Silicon Valley SaaS company around this, but was really focused on more of like a research experiment,
Right.
and it worked. And so I think maybe like December of that year then was when the idea went off in his head. He went and got an angel round of funding and really started looking to see, well, can we apply this more generally to a lot of these like manufacturing industries that while they're making high technology products, the actual processes and the technologies they're using as a part of supply chain, manufacturing, logistics are all decades old, right? So companies using systems like SAP and Oracle ERPs and things like that, companies doing a whole lot of this work through email, through sending somebody an Excel spreadsheet and they fill it in, and a week later you check it and you realize, wait, you did something wrong, let me send it back to you. And so that's sort of the space then that we were
Right.
starting to first grow in.
And so what Regrello really does, it allows companies to optimize their supply chain operations by really looking, leveraging multimodal capabilities to see where these inefficiencies may arise. Is that accurate, or do you
Yeah,
want to
yeah,
expand on
exactly
that?
right. And I think like first there was sort of table stakes just around, well, make it so these companies can represent their processes in a digital way. They can
Right.
get visibility into it. They can start to understand where are the redundancies, where are the bottlenecks, start to do like forecasting exercises. Imagine you want to nearshore and previously you're manufacturing in Southeast Asia, you want to move it to Central America. You need to understand what are all the pieces around compliance and logistics and that sort of stuff. So I think that was maybe like the first 2 years or so of the company. But all along, Aman, my CEO, and myself really had this vision of, well, once we get all this data into this workflow graph, then we can start applying both, say, traditional ML techniques, which are great and definitely have their place. And you should always look for the easiest solution to start driving value. But what we've seen in decades of building models in production is they don't generalize and they don't scale in a way where something you build for one particular vertical, one particular customer isn't really going to work for somebody
Right.
else. And so that's where now this last year really we've been leaning a lot into using foundational LLMs, using generative AI, and using multimodal models to really up the level of intelligence that we can add to these workflow processes.
Can I just stop you right there? The reason why is it rings a bell. So we've had experience of Activeloop, is the name of it. Sorry, we have some experiences across legal. I want to say sort of financial vertical where you have to do like a lot of like document matching and compliance checks and whatnot. In the legal, we have clients that help law firms file emails correctly and then generate new
Sure.
new contracts. supply chain is another industry that's like heavily kind of legacy and set in its ways. So I imagine the first kind of problem was like, hey, convince them to standardize their data, so you can like do something about it and help
Yep.
them grow. But how do you a lot of what you said resonated because what we see with all these types of companies, it's very it's kind of non-scalable growth because you develop this solution for this particular client for their particular problem, but then you have kind of hard time scaling. Is that why you were thinking about more general approach where you can like build higher level intelligence to kind of be able to handle multiple tasks and kind of scale that way?
Yeah, exactly right. And of course, there's nuances in a given region, in a given industry vertical, even within large manufacturer like
Right.
Bosch, within the different business units within a company. There's lots of differences, and there's a lot of proprietary data or data that is not, say, generally on the internet. And so that's where we have to take this multi-pronged approach of, well, let's use what are baked into all these foundational models. Let's use techniques like RAG to bring custom data from our specific customers, from specific industry verticals, all that sort of thing. It also allows us then to bring data that's very time sensitive, right? If you think of something like the stoppage that happened in the Suez Canal, what was that, last year?
Yeah.
So there's not, if you're looking at historical data of shipping routes, well, you're not going to find that information. And if you build a model with that window of time in there, it's going to be horribly, horribly wrong, right? Normally the Suez Canal doesn't stop. But meanwhile, if the Suez Canal is stopped and there's data on the internet showing, hey, there's a ship that's stuck there, getting that information in near real time and feeding that into, for example, you've got some purchase order estimate, and you say, oh, this should take 2 weeks to get to California, and really, no, it's going to take 6 weeks, and that's going to delay all these other things. So it's this multi-pronged approach of
Nice.
using foundational models, using RAG atop of that, building fine-tunings atop of that. And then there's cases where in particular, like LLMs, the way that they focus on natural language attention works spectacularly for so many use cases.
Can you kind of double tap on that?
Sure, yeah. So if you think of how just sort of the base transformer architecture that all LLMs are based off of today, you're essentially taking, a word that appears in a sentence, that appears in a paragraph, that appears in a page, and there's some relationship between the words left and right of it, up and down on the page, but fundamentally it's sort of how that relationship exists in natural language. So if you take something like a table instead, and you try to represent that through an LLM, it can do a decent job, right? You can put like a markdown table to ChatGPT, ask it some questions, what should this column be given this other data? It works okay, but if you swap the order of those columns, it will drastically change the output.
Right.
And it's fundamentally because natural language attention is left to right, top to bottom. You give that same data set to a business intelligence analyst or whatever, they don't care that the columns have switched, right?
Yes.
So there's even areas where we're working on novel deep learning research to understand, well, how can we have different types of attention that could focus on, if you're thinking of data from tariffs and ports and purchase orders and all of this sort of stuff, that's highly structured, highly numeric, highly tabular.
Well, it is very fascinating. And if we go back to, more messy data within the company that you have to kind of solve for that, how do you solve the multimodal retrieval component?
Sure. So this is where we've been relying heavily on Google's Gemini specifically, and have found it works quite decently well when it comes to any sort of task that previously you'd have to do custom OCR, you'd have to build custom models, right, to parse these types of invoices or these types of receipts or these types of images. And we've been finding, so both OpenAI's models, but specifically in production today, we're using the Gemini Pro series.
Nice. Have you tried Copilot at all?
I have not, no.
You should give it a try.
Okay.
That's
No,
what. So
I'll
for
look it up.
V4 and Activeloop, that's what kind of we fine tune Copilot to be better, a little bit better at all that. And what we do is we allow people to ingest kind of multimodal data natively thanks to Copilot, structure it into our format, and then make it very easily queryable. So you should give it a try.
We definitely will.
Model.
And that's definitely sort of the next step in this journey for us.
Yeah.
So today we're sort of taking data as these processes are running.
Right.
Maybe someone's submitting images and PDFs and also text, and some of it's structured and some of it's not.
Right.
And we want to be able then to make decisions, fill out data further downstream, right? Pull out the important bits. In particularly of importance to us is understanding where do we need human in the loop, where do we need to flag, hey, we're very certain of this and here's the evidence that shows us that you can move on to the next stage automatically, versus, oh, well, the model isn't quite as certain, here's what it thinks, but kind of flagging that to an end user to use their time in the best possible way.
So to paraphrase, you essentially are trying to say, hey, human in the loop, there is a lot of documents, but this one you should definitely take a look at because it might contain very valuable information.
Exactly, and in particular, we're looking for where there's potential risk, potential delay, those sorts of things. Where everything's running smoothly, great. We want our end users to be able to trust the machinery to just keep things running smoothly, make it so they don't have to go check their email, read these documents, go call the person and ask, hey, what did this mean, that sort of thing. But in order for them to build that trust, well, we need to, in the cases where it's not clear, or there's some delay, or there's some risk, to flag that, so then that's where these supply chain folks can come step in and sort of do the human magic.
Interesting. What interests me here is how do you make the decision as the VP of AI engineering of like, okay, so here is the cutoff where we stop ingesting stuff into Gemini, which is like amazingly cheap. So the context like is pretty big, and I imagine there are companies where you can make do with what they offer in terms of what was it now 1 million?
Yeah, and then 10 million,
yes,
I guess.
10, yes. So how are you viewing the trade-off, I guess, between in future we'll probably have infinite context length models. We kind of are starting to have this already, versus like saying, okay, this is like where we just do RAG.
Yeah, so it's an interesting question for us. I think where we're leaning more around RAG has to do with where our customers already have huge amounts of data.
Okay.
And they don't want to make it all freely available, right? It's not publicly available on the internet. We couldn't go train a generic model atop of it. But they do want to provide in a very sort of tenantized architecture a way for us to access it, bring it in at runtime.
Interesting. And do you find customers in the logistics industry be very hesitant to like feed data into?
Yeah, big time. And it's an area where even things like Gemini, it works great in our SaaS offering. But more and more, right, if you think of a lot of the manufacturing world, they're living in the on-prem world.
Right.
And so that's where we're leaning into models like Llama, where we're figuring out, well, how do we break down these complex problems into smaller tasks that, smaller models that we can go run on smaller sets of GPUs in a customer's private cloud or in an on-prem deployment. And so really sort of understanding, well, where do we want to push the envelope in terms of the absolute state of the art, run that in GCP or something like that. Versus, well, where are there parts of these problems that either for cost reasons, for speed reasons, or in particular for, say, like data locality, for compliance reasons, that sort of thing, we want to break down parts of the problem so we can go run it closer to where the customer is, maybe in their data center, things like that.
So would you say, is that where you start thinking about fine-tuning Llama, and then probably, have you fine-tuned Llama?
We have, and that's...
Have you been successful with it?
So for certain sets of problems, we have yet to find,
and
I was really excited to hear this talk this morning about Chameleon.
Yeah.
So we have yet to find a multimodal model that can compete with OpenAI or with Gemini. I'll definitely look up what you were referencing.
Yeah.
But that's sort of a stickler area where, okay, when it comes to natural language, when it comes to sort of breaking down a complex task into a chain of smaller, reasoning steps, that their models like Llama have been working decently well. But when it comes to this much more sort of complex, there's different documents of different modalities, and we want to be able to find the relevant ones, bring them in at runtime, and then maybe ask decisioning steps about it, right? So given this picture of spark plugs, well, do we need to actually go re-requisition an engineering change order, or was this just a bad shipment and we can move on with life, that sort of thing? So that's where I'm really, really curious to see sort of the state of the art of multimodal open source models develop, because at the end of the day, we have customers where they would want this to be able to run in an on-prem environment, in a private cloud environment, somewhere where it's not sort of GCP running it.
This is awesome. That's very interesting. So what other questions I think I have for you is what as you're helping your customers in logistics industry adopt more forward-thinking technologies. What are your top three concerns or things on your mind where you're thinking, okay, we're gonna build a tool in this exact way so we can address, we can deliver ROI to our clients, but how does that inform your product requirements or the roadmap?
Yeah, so it's a good question. I mean, I think a big one, as everyone has really leaned into deep learning, there's this risk of you lose the ability to understand what exactly is going on, why are these decisions being made, and it's very easy to sort of just treat it as a black box. There's this old XKCD comic, right, where it was saying, I want you to build me an app that from a photo can tell if you're in a national park. And they say, great, 2 minutes, we'll just look up the GeoIP. And if you're looking at a picture of a bird. And so this was not even 5 years ago. And the punchline of the comic is, oh, that's going to take a research team in 5 years.
Yeah.
The funny part is today, that also will take 5 minutes, right? Like you can just send it off to a commodified API and say, hey, here's a picture, is it a bird? And it'll tell you yes or no.
There's this famous YouTuber that you can send it to, and it'll
okay.
I'm joking.
But so great, like we can detect pictures of birds, and you don't need a research team to do that anymore. But as you start to get into complex decision making, you need the ability to understand like what are all the steps along the way, and use that to build trust with industry. So eventually, right, well, if this thing has been working and working successfully and it's flagging where things seem out of whack, and it's proceeding things along where they seem correct, great, people will start to trust it. But at least my experience in doing all sorts of applied machine learning is both from the point of view of the research team, from the engineering team, and even from, say, the customer standpoint, being able to get those checkpoints along the way to understand, well, what are the pieces here? What is being flagged as important versus not important? Not even necessarily allowing them to change that, but just have the insight into, okay, I see why it's doing this thing.
Got it.
And it's something with deep learning that gets much harder to do, but I think it's really important to think about, especially when you're thinking of more traditional industries like manufacturing.
Right. Interesting. And if you were to say, okay, so I get that part, but when you try to get people, I'm sorry, let me go back a little bit. So when you try to sell the solution, right, to people, what is your pitch look like? Is it hey, we're gonna save X% of your inefficiencies, and that on a larger volume we're gonna save you more money? Is that the case?
Yeah, so that's a big part of it.
Okay.
And right, so like fundamentally, a lot of these companies are using very old technology like SAP, right, or Oracle ERP.
Yeah.
And it's very wildly crazy for a 40-some person startup to say like, hey, you can throw away SAP that you're paying $500 million a year to upgrade, and you can use our startup solution.
Klarna is actually dropping Salesforce and SAP, and they're
so
like, we're going all LLM.
It's starting to happen.
Interesting.
And so I think sort of our pitch is, well, fundamentally we believe this vision that we can actually become a next generation ERP that's based all around generative AI, that's based around modern technology, all of that. But to get there, right, first we're going to look at, well, what are all these things around the periphery that a system like SAP is horrible at? And a big one is around change management, around dynamic processes. So if you think traditionally, right, I've got some process where I deal with my suppliers, and there's some custom-built HANA application in SAP that we contracted out to some contractor company. Now none of those people are there. We can't change it. Everyone just works around it, whatever. So a lot of Regrello's initial pitch is, well, those types of processes, actually you can digitize them, you can standardize them, and then you can iterate on them in days and in hours rather than months and years and whatever. And so that's sort of how we sink our teeth in. But then I think once our customers start to see the value, and well, as these things are digitized, then they all can sort of plug into one another. You can start to get efficiencies, not just in this one process, but across a whole bunch of them. And then now as we've really been leaning into, well, how can generative AI speed up creating them, speed up optimizing them, speed up just running them, and increase sort of validation rates, decrease human mistakes, catch supply chain fraud, all that type of stuff.
So what I'm hearing from you is you're saying, hey, first of all, we need to focus on understanding how to standardize everything, essentially, so we can help these people. Once you standardize, how can we improve the retrieval so we get the maximum amount of information so we can help the people, and then have some sort of agentic reasoning that's higher level and advanced, and probably like I'm assuming you have specialized agents for
Yep.
for different things, and I'm also gonna take a mental leap and assume that you're gonna have like a meta agent that would like say, hey, I need to call this particular agent that needs to complete this particular task. Is that
Exactly right? Yeah.
perfect? Good. I got it. You're great at explaining. In terms of the technology, what's your where do you think is the bottleneck? Is this a reasoning bottleneck right now? So it's like Regrello has already built the mechanism and the architecture, and we're just waiting for like the next iteration cycle of like more powerful models that will be like smarter. Or do you think that there is more work to be done? Retrieval, the guardrails, the human in the loop mechanism, all that kind of stuff.
So I think all of the above.
Okay.
Right? Like there are just limitations, even if we're just thinking of LLMs and sort of tasks that they're good at. There's limitations, there's context window limitations, there's all those sorts of things where we're just seeing leaps and bound improvement month over month, even not even year over year, right? What we were talking about before, where when it comes to multimodal processing, I feel the open source suite of models are lagging a bit behind closed source models like OpenAI or Gemini. And so that's an area of a lot of interest to us because manufacturing customers of ours want to be able to run these things in on-prem or in private cloud, not in sort of a SaaS environment.
Got it.
I do think there's some fundamental, say, architecture issues with using LLMs to answer questions about structured, numeric, type of data that is not fundamentally natural language based. And so that's an area where we're actively building a research team working on what we think of as like foundational tabular models as opposed to language models.
Interesting.
And then the reasoning piece of it is an interesting one where I feel like when I look at what OpenAI, the O1 has done so well, well, under the hood, and obviously I don't actually know, but my own sense from having built a lot of this stuff is under the hood, it's not that, hey, there's a powerful meta model that's able to actually go and do this reasoning. Rather, I think it's an engineering feat of, well, you break things down into smaller constituent problems and tasks, and then you have models that are supervising, well, what's going on there. We have systems in production where we'll actually go do, say, multiple RAG lookups, have different sort of weighting mechanisms, so pick different sorts of assets to bring in, send essentially then the same request with different context 5 times, and then have another model that's going to go score the output of all of them to decide, okay, what's going to feed into the next stage.
Very similar to paper QA.
Exactly. Yep. So I think that's where, rather than getting stronger and stronger LLMs, like it's going to happen, right? We'll have larger context windows, we'll have more parameters, quantization working better and better,
Right.
those sorts of things. But I think fundamentally the engineering feat of, well, how do you start to break these things down and build a complex system out of it is where I see the most advance in the next couple of years.
Awesome. Vijay, it's been amazing. Thank you so much for the interview, and I hope we chat again.
Yeah, thanks for having me.
Thank you.